Hello guys, welcome to another episode of Aadukalam podcast show. In today's episode, we have with us Prayag, who has a deep knowledge about space science and astrophysics. It was a really cool episode in which we talked about colonizing Mars, time travel and parallel universe also. There's timestamp in the description for you to follow, but I would recommend you guys to watch the entire video. So let's cut the crap out and dive into the video. So first of all, please introduce yourself to the listeners, Prayag.
Hey Lokesh, how are you? Thanks for having me on the show. So hey everyone, I'm Prayag Pandey. I'm an astrophysicist, or you can say an astrophysics student and researcher. Also, I have interest in tech, so I'm also a coder and an AI researcher studying AI and doing some research in that. But basically, my vision is to be an astrophysicist and research in that. And I've done courses from MIT. I'm doing BSc in physics with astrophysics, and I'm doing courses from MIT, Caltech, and University of Tokyo, and all sorts of things. So basically, my vision is to make sense of the cosmos for everyone, because not people understand the beauty of science the way it is. Okay, so my vision is to make sense of each and everything, because high school is the biggest destroyer of science, because if people going high school, if you study science, people say you're a nerd, and that's not the word that should be used for it. Science is beauty, physics is beauty, and you should get it. Okay, from the basics of equations, there are such beautiful equations for everything around us. I want to change that. Okay, because once the students, I personally teach students, and they didn't had any love in science, but now they're mad for science, they're mad for physics, just because I taught them the beauty of it. Okay, so yeah, that's my vision.
What do you think about colonizing Mars, the Elon Musk thing he's doing? What's your take on it?
Personally, I like Elon Musk. I like Jeff Bezos. I like Richard Branson. They are one of the best guys we have on this planet. Great innovators too. And there's not much to criticize in them. People criticize them. I know people criticize them, but I don't like that, because these people, okay, not these other people are also there. They're doing some great things for humanity, and you have to, give some respect to them. You have to be respectful to them. And Elon Musk, he's a great guy. He has done things on his own. He has passed through hardships and saved all of his companies and a lot of things. We all know about his history. So if you see the plan of colonizing Mars, why should we colonize Mars when we are having this much difficulties on our Earth, right?
Yeah.
People
Yes.
say it. So if you see, let me give you a great argument. The dinosaurs, the dinosaurs?
Yeah.
Dinosaurs didn't have a space program. That's why they vanished. That's why they went extinct. But we do have a space program. We are the smartest species that this planet has ever seen, right?
Yeah.
So we can use that to our benefit. Let's assume the dinosaurs or any other species had this space program, and they would have the chance to go out, have a backup plan. They would use that. We have that. We can use it. So let's use a backup plan when we have, okay? And let's develop not only Mars. We can colonize Venus too. We are already talking. I was in a conversation with NASA's chief scientist Jim Green, and I was listening to him, and he mentioned this, that NASA is planning to send reconnaissance missions on Venus. So if we can have a 3-planet habitat for us, that would be, how cool would that be? So that would be really cool. So terraforming Mars, by 2030 it will be possible. Not terraforming, first human will set foot there. Elon plans it to by 2025, but that's you can call it a far-fetched goal, or a very tight goal, very tight. But by 2030, certainly it will be possible, and the first missions will be research-based, totally research-based. All of them will be research, and after that, we can start by 2050. When the initial researches have been done, we can start sending people, and we can start forming an habitat there, terraforming it usually. So that's what I think. So the first challenge would be, the challenge with terraforming Mars is, Mars doesn't have an atmosphere. It has a very thin one, but what happened early in the past, Mars had an atmosphere, but the gravity of Mars is very less. Okay, and there is no magnetosphere too. Okay, so what happened, because of the solar radiations of the sun, the atmosphere of Mars was, ridden away. Okay, and it was eaten by that solar radiation. So it's not, there is very thin atmosphere that's not sustainable for us. So if, let's assume we are on Mars. Here on Earth, our atmosphere saves us from the UV rays and all kinds of cosmic radiation. But on Mars, we don't have that. So that's why we have liquid water here, because of the atmosphere. So that's a big benefit. Okay, having an atmosphere. So to have an atmosphere on Mars, Elon jokingly said this, that what we could do is uh, like detonate two bombs, atomic bombs, on the
Not
polar
in
cap.
yeah.
Yeah, because the polar caps of Mars have a lot of water. Okay, they have polar ice, water is frozen from, and that's a lot. That's a lot. So yeah, that's also a solution. That's a shortcut, but that's not a viable solution, because then what's gonna happen is, uh, if you're reading newspaper and you're seeing a blast here from Earth, and then in 100 years it will not be viable for us. Okay, the thing that I see, the solution that I see is, we have to just raise the temperature by 6 degrees Celsius. But just by 6 degrees Celsius, what's going to happen after that? The polar ice is going to melt, water vapor is going to be formed, and when the water vapor is formed, okay, water vapor is the best greenhouse gas. Okay, it causes a great greenhouse effect. The rest of the ice is going to melt after that, and then we are going to have an atmosphere. Okay, and to do that, we can direct some solar satellites, and direct that heat to the polar ice cap. Some water will start melting, water vapor is going to be formed, and then we can have, kind of liquid water on Mars after that. And it will take, I guess, 100 years for us, 150 years to completely terraform it. Again, we have to understand this. Life on Earth is unique. We cannot find that in our solar system, that kind of life. So we have to understand this. We should not destroy Earth in process of taking Mars and building Mars. And Mars can never be Earth. You have to understand this. But still, it can be a backup for us.
Yeah, and wow, that was very what to say. It seems possible when you say that. And what do you think about the cost of this and all? Like to terraform Mars and all, we have to pay. It's not like it's a debt for us, but we have to invest in it. So what's your take on it? Is it viable, and is it needed? We have this corona situation, pandemic and all, and yet there are billions of dollars flowing in space programs. So what's your take on it?
Well, I'll like to ask a counter question. Okay, I'll answer it myself. Okay,
Yeah.
so let me tell you, what's the budget of United States military? $900 billion. $900 billion. What's the budget of NASA? $22 billion. There's your answer, right?
Okay.
We're still not spending much. We're still spending much on military. We're spending much on all other things, but
Yeah.
not much on what do you call this? On space program. So it's a viable solution, yeah. And if you're talking about survival as human being, that's something that is intrinsic to our curiosity. Obviously, it's an option for us.
Yeah, and what about the space travel? Will the public, usual common person can do space travel in the near future, or it will be 50 years or 100 years from now?
Absolutely, we can. I've personally booked my flights on flights for suborbital space flight on Virgin Galactic and Blue Origin. Okay, yeah.
Oh.
Yeah, like I have done the application part. Then when the seats are available, I'll have to pay them money and all sorts of things. So I have already planned this. But let me tell you the future of space travel. What's it gonna be? You might have heard on July 11, Richard Branson is going to go through space. Okay, and on July 20, Jeff Bezos is going to space. So it's a space race that's already going among these billionaires. Okay, billionaires. So in the future, when by 2027, there is a company, I don't remember its name, but it's talking about building a space hotel. Okay, and there are already talks about building space station, orbital megastructures in space. So in the future, I'm talking, let's take 2035, 2040, we'll start seeing tourism as just like airline flights, like we see today. Okay, so like today, when the airline started, people had fear. People didn't wanted to take them, and there were a lot of constraints involved with that. Okay, a lot of variables we had to control. But now you can just sit down, hit an autopilot, button, and then the
Yeah.
flight take them wherever
Yes.
you want. So in the future, they are going to be much more common space travel, and it will be something like that's common for each and everyone, and we will be able to have that. So yeah, and it's also an interesting thing. Let's seeing
Yeah.
going into space and looking down on Earth, and we can also one effect that's gonna come, one benefit that I see, we can prove flat Earth is wrong. That's my that's my
Yeah,
mission.
exactly.
Yeah.
Okay. Yeah. There are a huge bunch
Yeah.
of people who think the earth is flat.
Yeah, yeah. So I want to prove them wrong. So that's my mission for going to for space travel.
Yeah, and also, what would be what is your imagination on space travel? Why would people go and take that space travel? Do you think there will be hotels or there will be malls over there in moon or somewhere else? What's your imagination? Why would people want to travel to space? Not, it's not at the starting stage. After it becomes very common to common people, then why would they go to space and all? What's your imagination?
Have a good vacation. Just like we
Okay.
go to Manali, just like we go to Switzerland, have a good
Okay.
vacation in space. You can just imagine having a vacation in space, having a family vacation, and having a vacation with your partner. That is going to be amazing. And what I see, my future, what I see, there's going to be obviously a lunar base by 2024. There's going to be a lunar base, but that will be again for research purpose. But in the future, when we start building other kinds, you might have seen the movie Ad Astra. I don't know,
Yeah.
you might have seen or not. So what happens in Ad Astra? You see McDonald's there, you see KFC and all sorts of these companies there. This is this is a property of humans. This is a property of humans. Wherever we go, we take things with us. So if you
Yeah.
talk about KFC and McDonald's, it's not what do you call this? There's not enough importance of it outside of Earth. Okay,
Mm.
outside of
Yeah.
Earth, it doesn't matter to anyone. Okay, let's assume there's an alien. It will not have any importance of that KFC in here. But we as humans, we have importance of that because we connected with it, and we're going to take it. So in the future, we'll see these space stations, we'll see these restaurants, we'll see these amusement parks, we'll see vacation hotels and all sorts of things in space, and that's gonna
Yeah.
happen. Also, you'll be able to take a vacation on Mars even when the terraforming is undergoing. So
Mm.
that's also future of space travel that I really want to see in my lifetime.
Oh. And actually, recently I saw a English series, The Expanse. I think you might have heard of it. The Expanse. Basically, there are three groups of people. One Earth people, and one are from Mars, and another are from the
Martian,
orbit.
asteroid belt.
Yeah, Martians, and yeah, and other will be like they will be called belters who live in the belt of other planets. So
Asteroid belt, yeah.
yeah, asteroid belt, and they would be fighting within themselves because of the natural resources. Earth is the only planet that the other two planets depend on the natural resources. So do you think like that and all will be really going to happen in the future if we colonize
Mm,
not only on Mars but in other planets also?
absolutely. That's gonna happen because once we colonize these planets, let's talk about 200 years after. I cannot imagine, I cannot predict the future because as Niels Bohr said, predicting the future is the hardest thing, to do. But let's assume things. That's what's gonna happen because we predicted a lot of things for 2020, 20, 30 years back, but they didn't happen. But let's take these constraints and variables and let's predict things. So for me, if we have the technology 200 years, and especially nuclear fusion is the technology I'm talking about, because as we talk about fuels and if we talk about propellant, we don't have much. We use even if we use nuclear fission, what happens is
Mm.
there's a lot of chemical waste, there's a lot of nuclear waste. But in nuclear fusion, just as in our star, if you sun, what it does, it converts hydrogen into helium, and there's a lot of energy generated, and there's no waste too. Okay, because helium is expensive here on Earth. Okay, so
Yeah.
helium can also be sold. So if we develop the technology of nuclear fusion in the future, that's going to help us. Okay, when we have that energy, when we have that good energy source, I think will be able to colonize not only other planets or not only build orbital megastructures in the asteroid belt, will be able to do a lot more things. Because if you see the recent mission about Psyche is an asteroid that's about $16,000 quadrillion, the worth of it is. And NASA has already planned a mission on site. Okay, NASA has already planned a mission on site, and they're already planning to send a rover or something like that there. So spacecraft there basically. So
Yeah.
these asteroids are so valuable. They have diamonds, they have gold, they have all kinds of natural resources. We don't have to deplete Earth then. Okay,
Yeah.
so there's a huge possibility there.
Yeah. What do you want to say about time travel, Prayag? Because is it possible at the first place?
Well, to understand time travel, you have to understand that it's not like science fiction movies. Okay, so science fiction movies have shown us this, that you open a wormhole or sort of thing, you travel through it, and you make a time travel machine, and you go to a particular, what do you call this,
Yeah.
timestamp in a
Yeah.
cosmos. But to understand time travel, there are two kinds. First, time travel in the past and time travel in the future. That's just the basics. So, let's talk about time travel in the past. Okay. So, time travel in the past, according to me and most of the physicists, cannot happen. Laws of nature are bound to prevent that. Let me tell you why. You might have read about the law of conservation of energy. The law of conservation of energy tells us nothing can be created, not it can be destroyed. The transition can happen. So out of thin air, you cannot create energy, right? But so in the same example, if you take energy or someone from this timestamp, like let's imagine 2021, and take them to 1947 in the past, you are creating energy out of thin air. That's not that's not an exact transition. That's just it. And also, you might have heard about the grandfather paradox. So the grandfather
Yes.
paradox is this: that let's imagine I make a time travel machine, or I open a wormhole. I go into the past. I kill my grandfather. If my grandfather is dead, I would not have been born. And if I am not born, how the heck am I able to go back into the past and kill my grandfather? That's a big paradox. Okay, so the laws of nature are bound to prevent something like that. Okay, time travel in past, you cannot do it. And time is something in which only you can move forward, you cannot go back. Okay, each and every second time is moving on. We can only go in one direction. Okay, the present and everything is past. Also, the time travel in future, that can be done, but again in a very different way. Why? uh, Again, there will be no time travel machine, there will be no wormholes, but just basic physics and Einstein's general relativity and special relativity too. So, what do I mean by time travel in the future, and how is it going to be done? Because it's a big thing that I'm saying right now. Let me tell you one thing. Once everything, what happens? You might have heard about time dilation. So, what does time dilation means? That you cannot go from one place to another in time. That's okay, but you can dilate time. So, what happens? 1 second for me, I could dilate it to 1 hour for somewhere else. Okay, you might have seen the famous movie Interstellar. What happens is,
Interstellar, yeah.
when the gravity, let's imagine a black hole. A black hole is having a lot of gravity. Okay, when the gravity is increased immensely, okay, the time dilates. Not only time, space and time both dilates because of immense gravity. So in Interstellar, you might have seen the black hole, and because of that black hole, the time was dilated. So 2 hours on that spaceship was like 20 or 30 years or something like
22, yeah.
Yeah, something like, I don't remember the exact
Yes.
calculation, but it was something like that. Okay, so if you take your spaceship, let me give you a simple example. Let's imagine I am here and I have a twin brother. Let's create him out of thin air for the sake of the discussion. I have a twin brother, and I sit in a spaceship. I go near the orbit at the event horizon of the black hole. I make one orbit in, let's imagine 1 year. I make one orbit, and then I come back to Earth. Okay, when I come back to Earth, I see my brother has aged 50 years. Okay, and I have just aged 1 year, and that can happen. That's like time traveling to the future, because when I come back to Earth, I am in the future. According to me, it's just 1 year. For him, it's 50 years. So, like that, we can do time travel in the future. Also, not only gravity, speed of light. If we approach the speed of light, let's imagine something approaches the speed of light. Okay, If you approach the speed of light, time will start moving slow for you. There is actually a Lorentz formula for this, but let's not go into the technicality. So if you approach the speed of light, the time is going to be dilated again for you. Time starts moving slowly for you than compared to someone else. So that's how that the same thing is going to happen. Try traveling in a spaceship at the speed of light and come back to Earth. You'll see your brother or your friend brother or something else. They have aged like 50 years or something like that. So that's just what time travel in the future.
But have you watched Endgame, Avengers Endgame?
Yes, I did.
Yeah, that they have talked about like if you go to the past, it won't change the future, but it will create a new timeline.
Yeah.
So, is that real, or it's just for the sake of the movie?
So, as a theoretical physicist, when these type of things happen, theoretical physicists actually imagine these things. You have to create like thought processes, and you have to create these imaginations. And imagination is the best thing. Einstein said, "Imagination trumps everything." So, let me tell you, even if that is possible, I'm not the creator of this universe, but let's imagine even if that is possible, there are going to be millions of timelines for each and every event. Okay? Yeah. And all of these timelines, if you say all of these timelines are being created, then that's kind of a chaos again. It's a chaos for universe. And universe, Einstein believed in a God. And Einstein God was very different. He didn't believe in a single creator that created all of the universe, and he said, "Let there be light," and all sorts of things. Okay, again, I'm not pointing to any religion. All of the religions I'm saying. Okay, so Einstein believed in a simplistic God, a God that created the universe, because the universe could have been in a lot of chaos. Okay, a lot of chaos could have been in this universe. Even if let me give an example. Even if the mass of proton would have been 20% heavier than the mass of neutron. Mass of proton and neutron are usually the same. Okay, just a little heavier. Neutron is just a little. Even if they would have been the same, what would have happened is, let's imagine 20% heavier. Proton is 20% heavier than the neutron. All the protons in this universe would have decayed into neutrons, and no atom would have been formed. This is a chaos. This is some fine tuning for life. So the universe could have been a lot of chaos, but it's not. Okay, and this chaos, those timelines will also be a chaos, and I generally don't believe in that.
Okay, but what if this timeline would be a possibility for human beings to live and everything in right proportion for us through nature itself? That may also be a possibility, right?
Yeah, it can be a possibility, but again, I'm not the creator of universe. I generally believe in the things that physics tells me right now. Okay, and theoretical physics is also involved in that. But personally, if you ask me, these separate timelines don't exist. You can talk about the parallel verse and the multiverse, but that's a different thing. Okay, parallel universes are a different thing. Quantum mechanics tells us parallel universe. Okay, but these multiple timelines, you might have seen that series Flash. And in Flash it shows these multiple timelines existing, right? And if you see the physics itself, if you see the what do you call this, the series, you might be convinced that these might exist, but actually that's not the case. According to me, that's not the case.
Okay. And also I want to talk about since you have taken the topic parallel universe, what is parallel universe and how different it would be in your imagination, bro?
Okay, so parallel universe is often what do you call this? Parallel universe, and there is a multiverse. Okay, multiverse. Okay. So let's talk about parallel universe first. So let me take you back to a trip to 1600 when Newton was there. Okay, 1600, 1700, and when he wrote his first book, Principia de Mathematica, something like that, or Principle of Mathematics. So in that he wrote about the three laws of motion, and then the law of gravitation Newton gave. And according to Newton's laws of gravitation, F is equal to G m1 m2 upon r square. That's just the law of gravitation. But actually that was not it. Einstein came it and reformed it, right? So according to Newton's laws of motion, or even if you take classical physics came after that. And according to what you can do is you can predict things for sure. If you know the velocity, if you know the acceleration of something, and then you can predict time, how much time it will take, or you take acceleration and time, you can predict speed, and all sorts of things can happen. You can use these classical mechanics, okay? But then in 1905, okay, from 1905 even take 1900, when Einstein gave for his theory of photoelectric effect, actually a lot of people say Einstein didn't believe in quantum mechanics, but actually he gave birth to quantum mechanics by his photoelectric effect, and that photoelectric effect highlighted the dual nature of light. That's the birth of quantum mechanics right there. But Einstein didn't believe in it because he was quite rooted in his initial beliefs because of general relativity, and he couldn't integrate this. And when he died, he had an open book at his desk. Where he was still trying to figure out what is the unified theory of physics. Anyways, so let's come back to this. When quantum mechanics came in, so quantum mechanics, when people starting figuring out Heisenberg uncertainty came in, Schrodinger's equation, and all sorts of things happened. So then we came to know, no, you cannot predict things for sure. You can know the probability of everything. So if you talk about electrons, we studied electrons are in orbit and all sorts of things, but that's actually not the case. Okay, electrons are in electron clouds, and you cannot predict the position of electron for sure. What you can do is you can find out the probability, 80% probability here, 20%, 10%, whatever kind of probability can happen. Quantum mechanics came in, and it was a wow moment for each and everyone. When I was introduced to quantum mechanics, it was a wow moment for me. What's happening? Okay, you cannot predict each and everything in this universe as you thought before. So now quantum mechanics tells us all sorts of things. And then there was Everett. So Everett told us this, and you might have heard about Schrodinger's cat. This cat is dead or alive, right? Okay.
Yeah,
so,
I have.
What happens is, if a cat is in a box, okay, and let's leave that. Okay, let me give you another example. What was the problem in quantum mechanics is this: when you see the wave functions. When you see the wave function of particular electrons or atoms you're observing, when we see them, like normally they have a wave function, particular wave function, but as soon as we observe them or try to observe them, that wave function collapses. Only the time when we observe it, that wave function collapses. Okay, so when you look away, the wave function is there. When you look at it, the wave function collapses. Why is it happening? Scientists were not able to figure out. Then that's why the cat is dead or alive until you open the box. Until you open it is in the superposition of these two states. Okay, so there is a superposition of these two states happening at the same time. The cat might be dead or alive at the same time. So then Everett came in, and Everett was trying to make sense of quantum mechanics, and Everett told us, actually that's not the case. We are also in superposition. When we are looking at the cat, we are also in superposition when we open the box. So it was quite unrealistic, okay, for us to say that we are in superposition. We are not in superposition.
And also, I think I have read somewhere that if there is no observer, then the universe doesn't exist.
See, that's the superposition. Yeah, when you look away and you're looking away and at the box at the same, that's a superposition. But we don't exist in superposition. That's not realistic. Then he refined his theory again. He said the cat, and the universe, all these three things, okay, there are two probabilities. These three things together are in a superposition, and for each and every outcome, for each and every outcome, there can be that's where the concept of parallel universe came in. You know, when we are looking at the cat, and we are actually looking at the cat alive, and when you're looking at the cat, but when it is dead, right? So see, the concept of parallel universes came from there, from quantum mechanics tells us. Okay, the superposition of each and everything, because something can exist and it cannot exist at the same time, and that's where the concept of parallel universes came in. That's just basic quantum mechanics. I tried to simplify it the best I can. Actually, I need equations to explain you and diagrams, but that's the best I tried.
Yeah. And what about multiverse?
Multiverse. So, okay, multiverse is something. For me, multiverse is a bubble universe. Normally, you might have heard bubble universes. So, what actually is a bubble universe? First, let me tell you uniqueness. Uniqueness is a concept since the earliest of our generations and civilizations. Uniqueness is a concept that we have considered Earth is unique. We have considered solar system is unique, and all sorts of these assumptions have been discarded in the past. So earlier we thought Earth is at the center, and then it came out that actually Sun is at the center, and the planets are revolving around it. And sorry for that. Then what happened is the unique concept of uniqueness was discarded. We thought there was only one Milky Way, and actually there was Shapley. He found out the what do you call this? The galactic clouds in our Milky Way, something like that. He predicted that all the universe was in our Milky Way. But then again, Hubble found other galaxies too. So uniqueness has always been discarded. People think there is only one universe now. Let's talk about the edge of universe. You cannot reach it ever because it's always expanding faster than the speed of light. But if you talk about one universe, there isn't one universe, because let's not be let's not make assumptions that there is only one universe and a universe is unique. So normally people say that there are bubbles of universes. Our universe is a single bubble in a sea of in a sea of other like millions of universes or multiverse. That's what a multiverse is. Let's imagine a bubble universe like ours, and there are other bubble universes having different characteristics and properties. So in each of these universes, the laws of physics might be different, the characteristics of physics might be different, but what we observe in our universe, it's always the same. Of course, so laws of physics here and laws of physics for an alien sitting at the end of this universe, they are going to be the same. Okay, we might interpret it differently, but the laws of physics are going to be always the same. So that's what a multiverse is. And you might say it's an absurd theory, it's a far-fetched theory, but currently we have some evidences that are pointing towards this. So if you talk about string theory, you might have heard about string theory. Okay, string theory is still a
Can you
theory.
explain it?
Yeah, I'll explain it. The string theory is still what do you call this? A theoretic. It's still a theory. There isn't observable evidence for it, but it's the best chance we have got. Okay, there isn't any theory to get a unified theory. Okay, so what actually string theory is and what's its purpose? So if you talk about Einstein's general relativity, okay, that it explains the world or the universe at the largest of scales. Einstein's general relativity talks about black holes, and it explains these stars and all sorts of things and how gravity forms around them. Okay, and if you talk about quantum mechanics, it explains the universe at the smallest of scales. So what do I mean by that? It talks about the electrons, quarks, and electron clouds, all sorts of things. So at the smallest of scales, right? But these two theories, the fundamental pillars of physics, modern physics, together they cannot. Together they rattle out. Okay, so yeah, they cannot sustain together. They cannot be both truly correct at the same time. Okay, so this is a big problem, and it's a dark cloud that has been looming over the horizon for the last 100 years for physicists. Why these both theories are not compatible together, and how to make them compatible. And there are all sorts of other forces too, like the weak theory and the electromagnetic and the nuclear forces and all sorts of them, and to combine and form a unified theory for physics. That's what Einstein wanted. That's what's the dream of every physicist around the world, to find a unified theory for physics, right? So string theory is the best chance for that. So string theory tries to marry them, like the unified, like the quantum mechanics and general relativity, and it tries to marry both of these concepts and create a unified theory of physics. That's what string theory is. And string theory says, you might have heard about atom. Inside an atom there are electrons, and there is a nucleus. Inside the nucleus are that's consisted of protons and neutrons. And even if you go inside protons and neutrons, you might see you might see quarks, like 3 quarks are present. And even if you go beyond that into the quantum realm, okay, so string theory says it's all there are strings there, and the vibration of these strings determine the vibrations of these strings determine the flow and characteristics of that particular atom or as a whole of the whole universe. So literally, like a vibration of a guitar string, these vibration, determine the characteristics of a particular element. So that's what string theory says in a nutshell. So string theory, and if you talk about dark energy is just this. Normally, if you throw a ball up in the air, okay, what's gonna happen is it's gonna come down, right? So in the universe, when the Big Bang happened and everything was going far away from each other, people thought after a period of time that energy is going to be, it's going to get zero, velocity is going to, or energy is going to be zero, and then it's going to get start back because gravity is going to act back, okay? But when Hubble in 1929 what he observed was the universe is not actually stopping or slowing down. It's actually moving at an away from everything in this universe is moving away at an accelerating rate. Okay, so he observed redshift in the galaxies, in the distant galaxies. That redshift usually means that that particular thing is moving away from us. Okay, so what he observed in this was that everything is moving away from us. So the farther the galaxy is, the fastest it is moving away from us. And it blew everyone, okay? So because this was a great revelation, the universe is expanding at an accelerating rate. People thought, why is it doing that? And that's where dark energy comes in, okay? Dark energy is actually responsible for the expansion of the universe. So what do I mean by dark energy? Why do I call it dark? Dark because we cannot see it. We can only observe its effect on its surroundings. That's why it's called dark energy. We still don't know what dark energy is. What are its characteristics? Is this a particle or a force? What it is? And is it an intrinsic property of space? Because space between things is expanding. So actually, why galaxies are moving far away, and what do I mean by expansion of space is, you are there and I am there, but we remain at a particular positions. We just move here and there, just a little bit. But the space between us itself is expanding because of dark energy at an accelerating rate. The space between us itself, this is space-time, this is itself is expanding, and that's why we are moving far away from each other. We are not actually running away from each other. The space between us is expanding, and that's because of dark energy. So dark energy, string theory, and these all things point towards a multiverse, because the value of dark energy in a universe is very precise. It's actually 0.120 into 10 to the power minus 120 or something like that. Very less, but still very precise. If it would have been a little bit more, matter would have been ripped apart. Everything would have been ripped apart, just like Thanos did. Okay, everything would have been ripped apart. If it would have been less, matter wouldn't have the chance to clump together and form us. So it's a very fine value of dark energy in our universe. So you might say, okay, why a fine value of universe, right? So why the fine value of universe? Because things exist, and this might not be the case in other universes. They might have a different value because it's not, again, uniqueness. We should not have a unique value. So other universes might have different values, and their life would have been formed, or life would have been destroyed, or other things would happen. So that's just the concept of multiverse.